Are you looking to take your SQL game to the next level? This session takes you beyond the basics of SQL querying. It's with instructor Alice Zhao. She is fantastic, and she is going to make this stuff easy for you to understand. And when you get your head around some of these concepts, it can really set you apart from other SQL users and put you into that advanced category. So tune in, try to practice some of the things that she's going to teach you here, and it'll really make a difference in your use of SQL and your data career. Enjoy.
Today, I'll be talking about going beyond the big six of SQL. So here is our agenda for today. I'm going to do a quick big six review to make sure we're all on the same page. And then I'm going to go through a lot in about 45 minutes. So I'm going to introduce a few functions. We'll talk about joins versus unions. We'll talk about timing queries, which we actually don't cover in any of our courses specifically, but we touch upon here and there. But this is a question I get all the time, so I want to bring this up in this course specifically, in this session specifically. We'll talk about subqueries, window functions, and then I'll walk through a really long example of my thought process as I go through a query. Okay, so for today, I'm going to be using the Pixar Films dataset, and this is the dataset from our last challenge. And I created this outline for today, and I'll say we've never done this outline before. This is new just for this spring session. So glad you're all here and hope you enjoy. Okay, so the first thing I'm going to do is I'm going to use my Pixar Films database, and the table we're going to be looking at today is this films table. So if you participate in the challenge, this is really familiar to you. You can see we have all these movies from Pixar. There are 28 total. Okay, so let's first do a big six review. So as I'm doing this, try to do this in your mind as well, because this is the foundational knowledge you need to follow along with everything else. So what I'm going to try to do here is find movies that have been released since 2010. So I'm going to do select all from films. This is what I always do the first time I write a query, is just look at everything. And then I take everything one step at a time. So what has been released since 2010? Well, it looks like I have to filter my data. So I'm going to take a look at the release date here. And I'm going to say it's since 2010. So I'm going to say greater than 2010, and then the first of that year. And technically it should be a greater than or equal to, because I want it to be since 2010. So you can see since 2010, these are all the movies. And then if I want to see the most recent one first, I can do an order by, and I can do release date descending. Okay, so now we have the most recent Pixar movie, and then it's sorted backwards. So we've just gone through 4 of the 6 clauses here. Select, from, where, and order by. And now with that, let's introduce the last 2, which are group by and having. So for this one, I'm going to find the number of movies given each rating. So let's look at our film data again. And you can look at the film rating column and see there are G films and PG films. So if I want to find movies with each rating, every time I hear that term, for each, with each, that means I have to do a group by. So I want to look at all the films, and I want to group everything by these film ratings. And the little tidbit with group by is whatever you put in the group by, you must put in the select. So I'm going to put that here. And for each film rating, what information do I want? So in this case, I want to count the number of films. Say count ID as my number of movies. And now I have for each film rating, the number of movies. And now the way that having works is once you have group data, you can now filter that data. So now that I have this, I can say having num movies, which is what I created in my select, greater than, let's say, 14. Okay, so that was a really quick overview. If that was too fast for you, I recommend you take John's MySQL Data Analysis course to really get a solid understanding here. But we just went through 6 different clauses. And you can see these are the 4 and these are the 2 extra. And one main thing to remember is with the clauses, they always have to be listed in a certain order. And that order is select, from, where, group by, having, order by. So that's my start Fridays with Grandma's homemade oatmeal phrase. Okay, that is your quick intro or review. Now let's dive into the new stuff. because we want to move beyond this. So what we're going to do is introduce some new functions. And when I first started with SQL, I did not realize how many functions were available. I had been using Excel a lot before, and I was familiar with Excel functions, but my mind was blown when I learned about SQL's functions. So I'm going to introduce 3 types of functions today: a date one, a numeric one, and a string one. And the way to think about that is, if you have numeric data, use a numeric function. If you have string data, use a string function. You don't really have to memorize that. It's just like to know the categories. So we're going to try to find the number of movies from each decade. So let's go up here. We'll do a select all from films again. And we're going to try to get the decade out of this. So let's think about how to do that step by step. We have the release date. And I'm actually just going to take a few of these columns for now. Okay, so we have this release date. How do we get the decade from here? Well, the first thing we have to do is just extract this year. So I'm going to use a date function to do this, which is called year. And I'm going to put release date in here. And now you can see we have the year extracted. So this is a date function because we use this on date data, and a function will take every value in a row, put it through some transformation, and then give you an output. So this is our output. Okay, so now we have the year, but we need to change that into a decade. So I'm going to do a little bit of finagling here, and we will change this to a decade. So the first thing I'm going to do is divide this by 10. And if I divide it by 10, you can see I get 1990 to almost 2000, right? It's almost what I need it to be. So what I'm going to do next is use this numeric function called floor. And if I do a floor of this, it rounds everything down. So now I have 1999, almost 2000. And to get it to the nearest decade, I have to take one more step. And if you're thinking you need to multiply everything by 10, then you are right. So now if I multiply everything by 10, you can see I get decades. And I was able to do that using a date function and a numeric function. And now my goal is to find the number of movies from each decade. So we're going to do the exact same thing as before. We have our decades, and I want the number of movies from each decade, right? So let's do a group by decade. And then for each group, what do I want? I want the number of movies. That's num movies. And now I have for each decade the number of movies. So just know that beyond the big 6, we're still using these same clauses, but we're just adding some functions here, and this will take you a step further when you're working with SQL. Okay, so we went through a date function, a numeric function. Now I want to talk about a string function. So what we're going to do is find the number of movies in each series. So let's take a look at our films again. And here are the films. And what I mean by each series is we have Toy Story, we have Toy Story 2, and so on. What if I want to know how many Toy Story movies there were? How many Cars movies there were? We could do this using SQL. Okay, so we're going to use something called a regular expression to do this. Now, if you haven't heard of regular expressions before, they're basically ways to find patterns. And this isn't just for SQL, this is for Excel, Python, just any coding language. The idea is instead of doing like a command F to find specific text, you search for a pattern. So I'm going to use a regular expression to find the pattern of basically, I'm going to find anything that has a space and a number at the very end of the text, and then remove it so that I can group all the Toy Stories together. And to do this, this is why I would use ChatGPT. So originally when I was creating this presentation, I was thinking, okay, this is all going to be about beyond the big 6 and just functions and keywords and SQL. But as I was developing it, I realized ChatGPT is so integral to how I write SQL code now. And so I want to walk you through how I would do that. So I'm going to write this prompt here, which is use a regular expression. And I'm going to say specifically in MySQL, because I'm using one flavor of SQL right now, which is MySQL, and that syntax might look slightly different than if you were using SQL Server or something else. And I'm going to say use regex in my SQL, and I want to extract the entire title of film except for the final space and number. So I'm going to copy all this over to ChatGPT, and it's going to give me some code to do this. So this is telling me to use the regex substring function. If you don't know what that is, that's fine. But you can see this is my example input, and this is what the output's going to look like. And I'm looking at the substring function, and I know that this is a complex way of doing this, so I'm actually going to just say, can you do that simpler? And this one is saying use substring index. That doesn't look simpler to me. Okay, guys, this is giving me a different answer than before. But when I did this, instead of using substring, regex substring, what I like to use is actually regex replace. Let me show you what that would look like. So if you were to use regex replace, this output is a bit simpler, and then I can explain exactly what's happening here. But I just wanted to show you the idea here is that even if you don't know exactly how to do it and you know the high-level idea, you can use ChatGPT. So this wasn't a great example of that because it still gave us a pretty complex output, but let me just show you what I was hoping it would give us. Okay, so let's take a look at what this regex replace is doing. What this is going to give us is the title of our film, which is actually called film here, and it's going to search for anything that is a space followed by a digit at the very end of a sentence and replace it with nothing. So I'm going to run this, and you can see what's happened to Toy Story. I'm actually going to bring those columns back. What's happened to Toy Story is it's gotten rid of that 2 at the end, and the same with Cars. And that's helpful for us if we want to find the number of movies in each series. So now that I have this information, this is a series. I'm going to say this as series. We can do our group by again. So here is each series, and now I'm going to do a group by off of that. So I'm going to say, just like before with the last 2 examples, for each group, for each series, show me the series, and then do account ID as num movies. And now you can see there have been 4 Toy Story movies, which is pretty wild. And this is a great chance to use the having, because now that I have this output, I can filter my data. So I'm going to say having num movies greater than 1. And that's how I can find all the Pixar movies that have multiple movies. Okay, so we just went through a lot right there, but the main takeaway I want you to get at this point is that you don't have to remember the syntax for everything. I use ChatGPT all the time, but the main thing to know is just the capabilities of SQL, and then you can have ChatGPT help you with the syntax. So in this situation up here, if I know that I can find a decade using SQL, I can use ChatGPT to help me come up with this crazy formula right here. And then for the regular expression, like I know that you can find patterns within SQL, and I know that you can do something like this. And so ChatGPT can give me the exact code for that. Okay, we are going to keep on moving on to joins and unions. So for joins and unions, what we're going to do first is combine the film and reviews table. So here's our film table that we've been working with. I'm going to pin that so we have that as reference. And then we're also going to take a look at the reviews table. So this is a different table now. You can see for each film, we have a bunch of the review data. So now we're going to combine these 2 together. So to do that, I'm going to do a join. So I'm going to say from the films table, I want to join that with the reviews table. And then I have to specify what the 2 have in common. So if I go back to films, you see there's this film column. So I'm going to do films.film. And then from the reviews table, there's also this films column, film. Okay, now if I run this, you can see both tables have been combined. Now, one thing you'll often do with a join is instead of writing films and reviews once again, I can call films F and reviews R, and then I'll call this F and this R. Okay, and I get the exact same output. So this is how a basic join works, but that's actually not the focus I want you to think about right now. When you're taking a look at this, you should notice that there is an ID missing. So what is happening? So let's take a look at our original film table again. I'm going to do a count, and you can see there are 28 films here. If I do a count of reviews, again, there are 28 films. But then if I do a count here, there's only 25. There is something wrong here. So how do we figure out what's wrong? The way I really like to do this is change my join type. So when you do an inner join, if I'm combining two tables, they're going to be joined on whenever two rows have a matching value, that's when it's going to be joined. But if I use something like a left join, then when those two are joined, then even if there's some mismatched rows, it's still going to output that for me. So what I'm going to do here is instead of this inner join, I'm going to do a left join. And if I do a left join here, then here you can see 1 to 28. These are all my rows to my left table. But then if you look on the right, there are some null values here. Okay, so that's interesting to us. So let's filter this so that we are only seeing these null values. Oh, yes, so we're only seeing these null values. So I'm going to do a where, and then from my reviews table, so my right table, I'm going to look at the cases where the film is null. And you can see these 3 films are null. Okay, that feels a bit odd. So let's take a look at the other table. What rows does the right table have that the left table doesn't? And to do that, I'm going to copy this down here, and I'm going to do a right join. And in this case, let me just show you what that looks like. With this right join, you can see I have all these here, and then there are some null values here. So I'm going to change my filter to be where the left table film is null. And if I run that, you see I get these 3 films here, which were the films we saw for the output of the left join. So what if we want to see both outputs together? Then this is a perfect situation to use a union. So for the next step, we want to find the mismatch rows. So what I'm going to do is copy or cut these and paste these down here. So you can see for this one, it gave me this output. For this one, it gave me this output. And if we want to see them stacked on top of one another, we can do a union. So if I do that, you can see these are our mismatch rows. And if you look at these films right here, you'll notice all these over here don't have punctuation, and all these over here do have punctuation, and that's why they're getting mismatched. So we're going to deal with that in just a sec, but I want to summarize everything we just covered here. We just talked about joining tables where we had our films and reviews table and we put them side by side. But then for matching or stacking tables, we used a union where we put them on top of one another. And my first key takeaway here is that people often talk about using joins and unions to be able to combine tables and do analysis, but I use it all the time to just explore my data and find mismatch rows. So that was an example that I want to show you. And then another key takeaway is that every RDBMS you use, so I'm using MySQL, but if you use SQL Server, Postgres, Oracle, all the syntax might be slightly different. Like you might not be able to do a right join if you're using SQLite. And in MySQL, I can't do an outer join where if you were in another tool, you could just write outer join and get all this as your output, but I can't do that in MySQL. So just know that the syntax is slightly different, but in general, it can do mainly the same things like joins and unions. Okay, so this next section, I'm very excited to share. This isn't something we taught before, but I just want to test it out today. So Next, I'd like to talk about timing queries. This is something I get asked about all the time. Like, how do I know which query is optimal versus not? So what I'm going to do here is first show you an example of a query that's probably not optimal, and then we can test it out and I can prove to you that it's not optimal. Okay, so what I'm going to do is first I want to say make the match happen. So you can see there's these films here. Like, what if we actually wanted those to line up correctly? What we can do is a bit advanced, but the good thing is we have ChatGPT here to help us. So if you think about it, these two columns of films are the same, right? They have the exact same capitalization, lowercase letters. The only difference is in the punctuation. So what if we strip the punctuation temporarily for this column right here? If we did that, we could match these two films up, and then we can move forward with our join. So what I'm going to do is I'm going to ask ChatGPT this. I'm going to say, I want you to join two tables, the films table and the reviews table, and specifically on the film column. So that's what we've done so far. But then I'm also saying the film column in the reviews table doesn't have punctuation. And let's see what it does with that. Hopefully ChatGPT will cooperate with me this time. Okay, so in this case, it's saying what you can do is you can change this on clause or this join condition. So I'm going to copy this over to our workbook over here, and let's talk about what's happening. I will say that ChatGPT did cooperate this time. So this is what I expected to happen. Okay, so here we are going to select everything from our films table, F. We're going to do an inner join. The default join type is an inner, which is why it wasn't there before, but I always like to be explicit with my joins. So I'm going to do an inner join, and then we're going to do this regex replace again. So we just talked about this earlier on, right? What a regex replace does is it finds some pattern, and then once it finds that pattern, you can replace it with a blank value. So what we're doing in this case is in this film column, we're going to find all the punctuation, and then we're going to replace it with nothing. And this isn't permanent. This is just temporarily. So this is going to be stripped of punctuation, and then we're going to set that equal to this film column. So let's run this. And you can see we have 1 all the way to 28. We have been able to match our two columns even though they were different. Okay, now you're probably thinking at this point, this is amazing. I want to do this all the time, but I'm going to pause you there because I want to say this is inefficient code. Whenever you're using regular expressions within SQL, it takes a lot of computational power. That said, I love to use them if I'm testing something out, but in the long term, the better thing to do would be not to use regex, but to actually change your data set so that it either does or doesn't have punctuation, and then you can join on that. Okay, but that was our intention, right? We wanted to create a query that is inefficient. And now that we have that, we can view the execution plans. So the execution plan is basically within SQL. Every time you run a query, it takes a series of steps behind the scenes to make your query run so you can get your output. So what we're going to do is view the execution plan for a standard inner join, and then we're going to also view it for this join right here. That's the inefficient one. And by doing this, we can see how long both queries take to run, what's inefficient, and so on. So the first thing I'm going to do is copy this down here. And then I'm just going to join on the film. So this was our basic inner join from earlier. And, oops, I think I'm getting an error here. Oh, I forgot my on keyword. Okay. This was my basic join from earlier. You can see it's missing this 2 here. But what we can do is add and explain analyze to this. And if I run this, this is my the explanation of how this query is getting run. So I'm actually going to copy this into ChatGPT so you can see it. But you can see there's so much happening here. It tells you the steps that it's taking, the time it takes. There's a lot going on. So I'm gonna keep that there. And then I'm also going to view the execution plan for this new query. So I'm gonna copy this down here. And let's view this execution plan. It looks the same, but it's not. Here's a second one. Okay, so just by looking at these as a human, there's so much going on and it's really hard to read. So what I'm gonna do is ask ChatGPT, help me understand these. So what it's gonna do now is hopefully format the output so it's a little bit easier for me to read as a human, and then also break down what's happening at each step. So this is telling me for this first, for the first plan, it's matching specifically on the film column, and the second one has this regex replace, which we know. But then the more important part is how long it's taking to do things. So with this first query, the main takeaway is when we look at something like this, this first step, this is the start time, and then you can see this is how long it takes, this 0.1. And then if we go down to the second query, you can see this is the start time, and then how long it takes is this 0.57. So the first one, the run time was only 0.1, and then the second time, the run time is 0.57. So you can see the second part, it takes, the second one here, it takes a lot longer to run. Okay, I just wanted to give you a quick intro to what that would look like. If you're interested in learning more, please let us know and we can develop a whole course on something like this. But there's just a lot of interesting things you can do, not just by querying, but also exploring how the queries work. Okay, so the main takeaway here is this second one took a lot longer to run, and that's something we should be aware of, even though the results are pretty cool. So the main takeaways that I wrote down here are, one, is that when you're using the on condition here, it doesn't always have to be a.b, a.id equals b.id, but instead you can have more complex things, you can have greater than and less thans. Just know that your code might run a little bit more inefficiently, but that's okay if you have a small data set. And then also you can view the execution plans to understand how the code is being run behind the scenes. And then finally, it's okay if your code is inefficient. I always say first write working code, then make it optimal. And we can do that using ChatGPT. So I don't know if it says this here, but oh, here it is. In the last time I ran this, it says, here's a recommendation. First, normalize the film column. So make sure that both columns are consistent in the database before you do any querying. So that's where ChatGPT can help you. Okay, we're at roughly the half-hour mark, which is right on time. And I'm going to jump into 2 more new concepts before we do one final walkthrough. So next, we're going to talk about window functions. And I feel like when I talk to beginners about SQL, window functions are always quite intimidating, but they don't have to be. So I'm going to show you 2 examples of window functions that I promise are not intimidating, and hopefully that will encourage you to explore them more. Okay, so first what we're going to do is make a new ID column for our combined data set. So let's just look at our combined data set one more time. We're going to use this one that doesn't have this regex replace in it. And if we look here, you can see our ID column is 1, 3, and it skips 2 and 4, right? So let's say we wanted to just smooth this out. We could use a window function to do this. So let me show you what that would look like. Let's say I have ID and film. Oh, whoops, I have to specify what table they're coming from. So they're both coming from my left table. And we have ID and film. And let's say we wanted to add a new ID column. I can do that using a window function called row number. So by doing this, this is going to give me a new ID. So I'm going to run this and then I'll explain it. Okay, if we run this, you can see we've created this new ID column. And this here is my window function. So not too bad, right? We just created a new ID column. But the idea of a window function versus a normal function is that it has some special capabilities that I haven't showcased yet here. So if we go back up here to these functions, like floor, year, regex, what they do is for a table, for every row of data, it's going to apply some transformation to every row of data. So that's a function you're familiar with. But in the case of a window function, it doesn't just have to apply that transformation to a single row of data, it does it to an entire window of data. So either the whole table is a window, certain subsets are windows, and so on. So when I just do an over here, this is saying apply this row number function to the whole table. And that's how I'm able to get all these IDs here. So that's your very first window function. Congratulations. Okay, so now let's go a little bit more complex, but not too bad. We're going to calculate the difference in IMDb score from the previous movie. So let me copy all this down here. And I'm going to bring in IMDb score. So, okay, I'm going to show you a quick hack that is often not recommended for efficiency, but I like to use all the time when I'm querying. If I want to just quickly see all the columns in another table, I can go to that table and do a dot star. And if I run that, you can see for my output here, I have all the columns from my right table. And now I know I just want IMDb score. So again, don't do this in your final code, but when you're querying, this is a nice hack. Okay, so let's pull out just the IMDb score. And what I'm going to do here is I want to know the difference from 8.3 to 7.9, 7.9 to 8.2, and so on. So let's do that. We are going to create a new column that's going to contain the prior movie's score. Okay, so I'm going to do a little bit of rearranging here. So we only have one ID column. I'm actually going to take this new ID, put it up here. And so now I just have new ID, film, IMDb score. Okay, so now with this, let's create a column for the last movie score. And to do that, I'm going to use the lag window function. And I'm going to call this IMDb score prior. And whenever I do a lag, I have to say what column's previous score do I want? Or what column's previous value do I want? In this case, I want IMDb score. And if I run that, you can see now I have the prior movie score. So here's Finding Nemo score, but then this is Toy Story 2 score. And now with this, I can start calculating some differences. So to find the difference between last year's score and this year's score, what I can do is take the IMDb score and subtract last year's, which I've captured in this new column here. So I am going to take the current score, subtract this score, and then I'm going to save that as IMDb score difference. And whoops, it's because I have this extra as here that I'm getting an error. Okay, let's try that. Okay, so with that, we have calculated the difference between these two scores, and this is a huge value. So I'm just going to round that to 1 decimal place. And now we have all these differences. So you can see from year to year, this is a really negative difference. We went from beloved Toy Story to, I guess, people give Cars a hard time. But then here's the increase. Again, people give Cars a hard time, but then Coco did really well. So you can see we were able to make that calculation by using window functions. Okay, so the key takeaway here is these were all pretty complex if you haven't been exposed to window functions before, but just know that if you have a data manipulation idea that you've done in Excel before, you can probably do it in SQL. The main thing to know is these general ideas of what a window function is, what it can do. And then with that, you can then just use ChatGPT to help you with the exact syntax, but really you want to try to use the steps I'm doing to work on it step by step. Okay, now let's move on to, I think this might be my final, this might be the final section. We'll see how much we can get. Okay, so if we move on to subqueries and CTEs, what we're going to try to do is filter out the null values from this output. So let's say we just made this calculation here. And you have this null row, and you don't want that null row there. So let's say you want to filter it out. You would say where IMDb score diff is not null, because I don't want the nulls. And if I ran this, I would get an error. And you can't see this, but it says unknown column IMDb score diff. And the reason for that is because of execution order. So even though we define IMDb score diff up here, we can't use it down here because in SQL, what happens is that the clauses are executed in a certain order, in the normal order that you would write them, except select, it's way at the bottom. It's not the last one, but it's pretty far down there. So this clause gets run first, your tables get joined, then the where clause gets run, and that's when you do your filters, and then the select clause gets run. So at this point, IMDb score diff hasn't been defined yet. And so what we need to do is, well, you could rewrite this whole query here, but what I like to do is use a subquery. So let me explain what that would look like. So I'm going to run this, and you can see I have my output here, and I just really want to filter this data. So whenever I come across a situation, I like to temporarily save my output here as something so that I can write a query on it. So what I'm going to do is put parentheses around this and then save it as a subquery. You can name it anything, but I'm going to save this output as a subquery. And now I can treat this whole thing or this whole output here as just another table, and I can start writing queries on it. So I'm going to say select all from this. And if I run this, you'll see I get the exact same output. But now the nice thing is that IMDb score diff has been locked in as a column, and now I can filter on it. So I'm going to say where, and then IMDb score diff is not null. And if I run this one more time, you can see I filter that data. So if you've ever run into the issue where you're writing something in your select statement and your select clause and you want to filter on it and you can't, this is your solution. Create a subquery. But taking this to another level, instead of just creating a subquery, I actually like to use CTEs instead. So subqueries have been around for a long time. The CTEs are mainly available in newer RDBMSs. I say newer, but it's been around for about 10 years, but they were not around when I first learned SQL. So now that they are around, I still default to subqueries sometimes, but CTEs do the exact same thing. It's just a different way of organizing everything. So again, let's move back to this query right here. With this query, we had our null values, and let's say we wanted to, again, filter these out, but this time we're not going to use the subquery, we're going to use the CTE. So I'm going to copy all the code to get this output. And then down here, I am going to save this output as a CTE. So with is the keyword for a CTE. I'm going to say with CTE as. I'm going to paste this whole thing down here. And then I can go forth and do my select all from CTE. And I get the same output. So the main thing here is I did the exact same thing in both these cases. I saved what was in parentheses as some temporary output, and then I queried it. The only difference is that for a subquery, it's in the middle of your query, but then for a CTE, you define it up front at the very top, And then you can just write select statements as usual down here. So we've selected everything from our CTE, and now we can filter. I'm going to do where IMDb score diff is not null. And now I get that null value removed. So the first key takeaway here is it's important to understand query order versus execution order. But I just like to think about it as everything is in the right order, except select is further on down. And then I love using CTEs to solve problems step by step. Whenever you see an output and you're like, okay, I want to save this output, then use a CTE, save that as a CTE, and then you can go on to your next step. And then that way you can drill down on your solution. Okay, so with that, I'm not going to do this final step-by-step walkthrough, but this is something you can try on your own after this session. We're going to send out all the code for this along with the corresponding solutions. But to find the top-rated movies for each decade, I would walk through it in a step-by-step fashion using CTE by CTE. Okay, so with that, this was our agenda for today. The final takeaways are work step by step. You see, I did a lot of trial and error. I love using CTEs to see my result, filter it down, do some aggregation. I just use tons of CTEs. And then it's okay to start with bad code. Use ChatGPT for all the finishing touches. A lot of times, the last thing I do after I write a query is I put the whole thing in ChatGPT and I just say, optimize me. And then it rewrites it for me, but at least I understand the structure. And that's what I say here too. The most important thing is to understand the general structure and don't worry too much about memorizing syntax. I need help for this all the time, but because I understand these main concepts, I'm able to be a successful SQL writer. So the next steps here are, if you want to really solidify the basics, I would recommend taking John's course. And then if you want to dive deeper into all these topics, you can check out my advanced SQL querying course.
Amazing, Alice. There was lots of great engagement here, and some questions that have been coming in. So we've got a little bit of extra time. If you're game to get on the hot seat and field some live Q&A, it's always my favorite part of these sessions.
Yeah, sounds great.
Let me pull up. Actually, saw Mohammed asked the same question a couple times in the chat. So I want to start with Mohammed's question. Why are you using MySQL? Why don't you use Postgres?
Oh, that's just specific to whatever company you're working at. So the first company I worked at, we used SQL Server. Then we used Teradata. Last company I worked at, we used Postgres. Maven uses MySQL. So it's just whatever your company uses.
Yeah, I'll have a follow-up question, Alice, for that. So you started with SQL Server. How hard was it for you to go from SQL Server to Teradata relative to like how hard it was to learn SQL Server in the first place?
Oh, not too bad at all. Because I would say like 80, you know this, John, like 80 to 90% of the code is roughly the same. Yep. The one thing I did not realize though is I just kept Googling things like how to write this in SQL. And then my code wouldn't work. And then I learned, oh, you have to add MySQL. You have to add Teradata. Like you have to add those and then you'll get that syntax. So.
Yeah, mostly they can do the same things. Sometimes it might say limit to 50 rows. Sometimes you might say the top 50 rows, which accomplish the same thing. So yeah, knowing your syntax language is important. But basically, like I felt like once I learned one, it was so much easier to learn all the others as I switched jobs and went to other shops. So
I feel like it's kind of like learning Excel and then learning Google Sheets, right? It's just ever so slightly different.
Yep, totally. Let's see. So this is from Donnelly. Question here: are there instances where one must use a subquery and a CTE would not work?
Oh, that's a great question. I would say it's probably okay. So the instances where you have to use a subquery is if you're using older software that doesn't support CTEs. Mm-hmm. So that's the first part. But I would say it's actually like typically the opposite. Subqueries and CTEs, if you're using newer software, will do the same thing. But with a CTE, you can do more. because with CTEs, you can create recursive CTEs, you can reference the CTE multiple times.
Yep.
So I would just say use the CTE, but sometimes I just default to subqueries because that's what I started with.
Yeah.
Use a
Yeah.
CTE.
And I think I'll see if I can find, I think I have a blog post on the Maven blog about CTEs versus subqueries, and same thing. Like, I think for something that's real quick and dirty, it doesn't matter that much. Where a CTE or using like a temporary table blows the doors off of it is if you start getting into like multi-step stuff where you really have to transform the data. Subqueries get really nasty pretty fast and hard to follow. Like if you have nested subqueries, forget about it. It's like you're like, okay, which one's the inner subquery, and then this is the second layer. It gets very complicated very fast. Whereas like Alice is saying, if you define a CTE, then you can reference that multiple times, and it's much more linear to follow the sort of the program that you're running. So yeah.
Oh, and one more thing with that, I will say there are some. I want to caveat what I just said, because there are some situations where you would just use the subquery. Like if you're filtering by something in the where clause, like you would filter by a subquery. So that gets like very detailed. So like that we talk about in the advanced course, but like for the most part, if you're working with tables, use CTs.
Yep. Awesome. Let's see. What do we have here? Let's see. Oh, here's a good question. This is from Vasilis. Are CTEs more memory efficient compared to subqueries? And could you provide a short explanation of recursive CTEs, which you mentioned?
Sure. So I always get this question. And this is one where I say, when in doubt, test it out. Because the answer is maybe. Sometimes it depends on your RDBMS. Like in theory, it's supposed to be yes. In theory, they should actually run the same, right? Because you're just like saving this temporarily. But then it depends. So that's when you would have to use that like explain analyze that I walked through to see what's actually getting run. The second question on recursive CTEs, the recursive CTE is more complex. It's not used that often, but the idea is that the whatever's in the CTE, it references itself. So common use cases are one, if you're trying to generate a series of something. So basically like it references itself and then adds one. If it references itself, it adds one. Or another one is if you have a parent-child hierarchy. So if you're interested in that, take a look at our data drill from last month. And we're trying to map a parent-child hierarchy like in an organization, and you can use the recursive CT to do that.
Awesome. This one is less of a question, but I think it's great. This is from Nilaba. Thank you, Alice, for your unsupervised learning and data science prep courses. I've learned a lot from these courses. I really enjoyed today's session. You are a wonderful instructor. So no question there, but have to agree with everything there. So just worth putting that up there for you, Alice. There's been a lot of comments like that in the chat. I know you've been focused on the demo, but a lot of love coming your way. No surprise whatsoever.
Oh, thanks so much. And I will say, if you are interested in the data science path, we have another data science course coming out very soon. We're currently working on the NLP course. So
and what do we think? Is that like around June 1st-ish, Alice? Would you guess?
Around,
I'm putting her on the spot right now.
Yeah, around a month. I'm currently recording. So yes.
Awesome. Amazing. Yeah. Alice and Enrique and the whole team are working on getting that one shipped out. There was a question about that earlier too in the chat as well. So people know what's coming up. It's awesome to see people know our roadmap. Let's see what other questions we have here. I'm just going to check the chat real quick because we got a few more minutes. If I missed anything here, let's see. Here's one for you, Alice. If somebody's brand new, do you think they should they jump into your advanced SQL course, or would you start them with the MySQL data analysis for training wheels?
I would still start with the basic course.
Basic first, yeah.
So in the advanced course, I do a review, but I feel like it's kind of like learning addition before you learn multiplication. You just need to have a really solid foundation so that you can quickly get up to speed. You could do it, but
yeah, could struggle. Yeah, always good to have a good foundation. Let's see. We've got this one from Deep. It says, if you sign up for classes, will the boot camp assist with job searches? That's not really the focus of our, like, they're more focused on deep learning of the technical skills, the current boot camps. A few years ago, we did have one where we had like a job guarantee and we helped people with placement, stuff like that. But it's not something we're really leaning into right now. But great question. Sorry, we do have a launching your data career path where we do help folks through self-paced learning with making a better resume, with better LinkedIn presence and networking, and with interview prep there. So that's not through the boot camp specifically, but through the self-paced courses. I think one more question, or a couple more questions here. Awesome. Let's see. So this is from Kimoon. Alice, if I wanted to get the IMDb score difference between sequels only, is there an easy way to do that? Oh, interesting.
Oh, yeah, you can absolutely do that. So if I think back to the question, yeah, you would filter, if you would filter first by sequels, right? And then you would take the IMDb score, then do the window function to take the differences. So this is a great example of, you could either all do that in one step, or you could do the step-by-step with CTE approach. So it's like you first filter by sequels. Once you get that, save it as a CTE. Then you find the differences. That's a great extension of that question.
Yeah, it's awesome. Great questions, guys. Let's see. Okay, this is one more from Khalid. Thank you, Alice. CTEs are great. My question is, I get a certain output using a CTE and further deep dive into that output for further analysis. However, unlike a subquery, I cannot do that again and again. How do I resolve that using CTEs? By the way, using SQL Server.
Okay, I would say for this one, from my experience, once you get to a certain CTE, you can keep diving into that one.
Yeah, I haven't used SQL Server in a while, but like in other implementations that I have been using, you definitely can reference it multiple times. So I'm not really sure. Maybe SQL Server is different. Honestly, it's been a decade since I've used SQL Server, but.
Yeah, I would say I agree with John. I think it should work, but then this is like a case-by-case basis. So, yeah.
Thank you guys for joining. Alice, thank you so much. Folks, please give Alice some love here in the chat for a truly fantastic session. We really appreciate it.
Thanks, everyone.
Bye, everybody.